Okay, this is the first time I'm doing a recorded lesson. It's a little bit weird, but let's see if we can do it in one take. So we're going to look first at resistance in series and a parallel circuit. This is a required practical. You need to know methods, you need to know what you're going to measure, you need to know what you're going to use the measurements to calculate. We're looking at first resistance in series and then in parallel. So below we've got a simple circuit diagram. We have a battery, we have an ammeter, we have a resistor. The battery is providing the voltage of the circuit, the resistor is reducing the current, it's affecting how the electrons are flowing in that circuit, and the ammeter is controlling how we measure the current flowing through that circuit. We're also going to look at how the resistance changes in a parallel circuit as well. So the experiment's really simple and we can simulate it quite easily. Here I've got a cell. This has given me 9 volts. I have an ammeter to record the current, and I can add a resistor to complete the circuit. And it gives me a current of 0.9 amps. And I can add another resistor, which will give me a different current of 0.45 amps. And another resistor, of 0.3 amps. And we're already getting a little squash to space, so I'll move my wires along and cut a wire and add a 4th resistor, all in series, to get a current of 0.22 amps. And we'll do one more, we'll do a 5th resistor, all of the same value, and you can tell that by the different stripes. Those stripes tell you the resistance levels. You don't need to know that for your exam, just a little bit of information. And that's a current of 0.18 amps. And I've plotted that in my graph here. Let's make that a little bit all the points. And as I increase the number of resistors, the current is going down. Now what you think, what type of graph is this? Is it a straight line graph? Is it directly proportional? How could you describe the relationship between the current and the number of resistors? Okay, it's an important skill for your exam, is to describe the relationship between those two parts. Okay, now there's something else we can do with this, because plotting just the number of resistors and the currents isn't that interesting. What I really want to know is what happens to the total resistance when I increase the number of resistors. Now there's an equation that you need to know that you should have already covered that relates the current, the resistance, and the potential difference in a circuit. Okay, and in the method here it says that we need to use that equation, that V equals IR, the voltage equals the current times by the resistance, to calculate that resistance. So for each resistor I need to take my potential difference and divide it by the current. Now the potential difference, you need to remember, in the circuit comes from this battery, which is 9 volts. So I can put in a little column that's potential difference, measured in volts, and I can add another column to calculate the resistance, measured in ohms, and I can do a quick equation, because this was all 9 volts, and we do the current, okay, underneath that potential difference, the voltage divided by the current. Okay, so equals divided by the current. And I get a resistance of 10 ohms. And we can just double check that that's true. If I click on my resistor in the circuit, I have a 10 ohm resistor, and each of those resistors is the same value. 10 ohms, and I can drag that equation down, and the resistance seems to increase. which makes sense. I'm adding more resistance to the circuit, the resistance goes up. So I can move that graph out of the way. And this time, I'm going to plot the number of resistors against resistance. The number of resistance against resistance, insert a graph. And I have a beautiful graph where we have resistance along the y-axis and the number of resistors along the x-axis. Now again, I want you to look at this graph and think about the relationship. You need to be able to describe the pattern. And this graph is directly proportional. You need to know and recognize the fact that it is a straight line that will fit through 0. Okay, I can add a trend line to it. Or maybe I can't add a trend line to it. A trend line could be added to this graph and it would be a beautiful straight line that goes through 0. Okay, and that is that relationship between the resistance and the number of resistors. It's very straightforward. All we're doing is adding up the resistors. Okay, when I have 1 resistor in the circuit, the total resistance is 10. When I have 2, the total resistance is 20. When I have 3, it's 30. When I have 4, it's not quite 40, just because the measurement of that current isn't really precise. It's going to round to some number here. Okay, that's the relationship between the resistance in a series circuit. In my next video, we'll look at the resistance in a parallel circuit. Now we can start using this information to start entering and reading about resistance in the Seneca Learn package. So I'm just going to take you through how to sign in and log into that quickly. So you need to go to Seneca, you'll need to log in, you'll need to go to classes and assignments, you'll need to go to the year 10 class. Okay, if you haven't already joined it, you can join the class through this button, enter the code that you can get from class charts and in class charts from me and from Mr. McQueen. We can go into this, we can click on the physics section, chemistry and biology also here. We move through the different topics and we want to look at electricity. Okay, this is what our assignment is on, and we can move down to resistance. We can click on resistance here and we can start learning. Okay, and we have all this information about how resistance is affected by various different things in circuits. I hope you're having fun at home. My next video will also include the joke of the day.